Hey guys, how are you doing? So I just wanted to pick up where we left off last week, which was we started talking about rational or fractional exponents. And if you remember, we did actually the first four, but just as a recap, we said that this number down here is called it's called the index. I'm not sure if I actually said that or not, but we would call it a root. So like this 3 down here means this is a cube root. All right. This 4 right here would be called the index, but it would indicate that it's the 4th root. All right. And we said that these are equivalent to the square roots or the cube roots or whatever that we've been talking about. We've been only talking about square roots. Again, square roots look like that when we put that symbol. But if we want some other root, then we said that on this little ledge right here, I call it diving board, but on there we would put that index right here. So if there were a 3 right there, that implies that this is the cube root. And what that means is now I'm looking for a number that multiplies together 3 times to get whatever's under here. So again, if we had an 8, that would say find a number that when I multiply it together 3 times gives me 8. And then this would be 2, because 2 times 2 times 2, 3 times, gives me 8. Right? And then if we had a 4 here, that would say it was the 4th root. And that would be, let's say, the 4th root of 16. I'm looking for a number that when I multiply it together 4 times gives me 16. Again, that would be 2, because 2 times 2 times 2 times 2 gives me 16. All right, and so then we note that there is no index that's written here on the square root, and that's just because it's implied. It's so common we don't bother to write it, but if you wanted to, you could put a square there, or I'm sorry, a 2 there for square root. People just don't kind of like, it's an implied 1 as the coefficient when we have an x right there. We just assume that it's a 1. That we assume that if there is no exponent on something, that it's an x to the first power. It's because it's so common that we don't bother to write it. So again, that 2 just doesn't usually show up. If you've just got that symbol right there, we assume that you mean square root. Okay, so then we talked about how we would just go through here and interpret this as being the cube root of 8. And we would say that's 2. Or we would say the cube root of 27. That's 3 times 3 times 3. And so therefore, the cube root of 27 is 3. We did the cube root of 64. And we found out that that was 4, because 4 times 4 times 4 is 64. And then we did the 4th root of 16. And we said that that was 2. Because 2 times 2 times 2 times 2, 4 times is 16. All right, so we stopped there. So let's just do one more, since this is the first time we're seeing it again, since just under a week. So this right here means the same thing as the 4th root of 81. And then we would say, okay, if I take some number and multiply it together 4 times, it should give me 81. What number does that? Now, if you're looking at these and you're like, I have no idea. I don't know what multiplies together 4 times to give me 81. My suggestion to you is just start with 2 and try it. Right? If it doesn't work, move to 3. But things like cube roots, 4th roots, 5th roots, when we do the reverse to try to figure out what power it is or what number to that power gives us the inside number, they grow extremely fast. And so chances are it's going to be something 5 or under. It's really not going to be that big. So if you aren't sure, then just start guessing and see what works. So if I put in 2 here, 2 times 2 times 2 times 2, no, that's 16. That wouldn't work. So then let's try 3s. 3 times 3 times 3 times 3. Well, 3 times 3 is 9. And 3 times 3 is 9, and 9 times 9 is 81. So yes, the 4th root of 81 is 3. All right, so I'm going to pause for just a second here and let you fill in 6, 7, and 8. Again, these are all back to our square root, so this should be a piece of cake for you. So just pause the video right now and go ahead and do 6, 7, and 8 on your own. Okay, so hopefully when you did these, you got the square root of 4 is 2, the square root of 9 is 3, and the square root of 25 is 5. All right, so now we have ones, and again, we started to talk about this at the very end of class last week, and that is, what are you doing here when you put that 2 up top, all right? I was okay with 8 to the 1/3 power, but what does that mean if I now have 8 to the 2/3 power? And again, we started to talk about this at the end of class last Thursday. 8 to the 2/3 is the same thing as saying 8 to the 1/3 squared. Right, 8 to the 1/3 squared. Why? Well, let's use our exponent rules. What happens when I take an exponent? That just doesn't even look like a 1/3. When I take some exponent and raise it to another exponent, all right, the rule is that I multiply them together. So if I multiplied the 2 times the 1/3, I would get right back to the 8 to the 2/3. All right, so 8 to the 2/3 can be essentially unmultiplied into 8 to the 1/3 squared. All right, what is 8 to the 1/3? We just did that up in problem number 1. 8 to the 1/3, or the cube root of 8, is 2. So we figured out what the inside part is, but don't forget we still have that squared on the outside. All right, so that would say, now that I've taken the cube root of 8, I need to square it, and I would get 4 as my answer. All right, and so what we talked about in class last time was how if we think of this fraction 2/3, and this is kind of like the ground right here, and I'm going to put a little flower right here. That's such a bad drawing. All right, and these are the roots right here, so this is how a plant grows, is that it's got the plant on the top, or a flower up top. We're going to go with flower right here, and I'm going to draw a tulip because I'm not an artist. All right, so we're going to say that the root right here, the cube root, the 4th root, the 5th root, whatever it is, the roots are on the bottom, just like in a plant, the roots are on the bottom of the plant, right, under the ground. So the thing under our fraction bar is the root, so the cube root, the 4th root. And the thing on top, above the ground, above the fraction bar here, is like the flower. And again, this we would call the power, right? To raise it to the 2nd power, raise it to the 4th power, raise it to the 10th power. So flower, power, right? Both go above that horizontal line. In this case, it's the fraction bar. In this case, it's the ground. And then the thing that is below the fraction bar, below the ground, is the root, all right? Cube root, 4th root, 5th root, and the root of the plant right here. So just remember the top is the power, rhymes with flower, and the bottom is the root, and it's just like the root of a plant. Okay, let's take a look at number 10. So in number 10, it's saying that we want to take 27 and raise it to the 2/3 power. And again, that means 27 cube root and then square it. All right, so take the cube root of 27 and square it. So what is the cube root of 27? Hopefully you're saying, it's 3. I remember that from problem 2. All right, so we take the cube root of 27 and then we square it, and we get 9. All right. So I'm just going to flip this sheet over for just a second because I want to demonstrate something about this problem. So 27 to the 2/3. Now some of you might be thinking, well, why didn't you do 27 squared to the 1/3? Or could you do 27 squared to the 1/3? Because when I multiply these together, I get back to this. So why did I choose to do instead 27 to the 1/3 squared? Right? Is there something significant about that? Is it just easier? So the answer is that these, if I do 27 squared and I take the cube root, or if I do 27 cube root and then square it, I will get exactly the same answer. The answer to both of these is 9. However, I want you to remember what happened here. When I take the cube root of 27, it makes it a smaller number. It brings it down to 3, and then it asks me to make it bigger by squaring. And so I end up with 9. If I did 27 squared, which I don't even know what that is, so I'm going to do it right now, I get 729. And it's then asking me to take the cube root of it. All right, so I don't know how many of you know your cube roots. Again, some of you should know your cube roots from memory work, but I don't know how many of you do know them. If you remember your cube roots from memory work, you would remember that the cube root of 729 is 9. However, most people lose their intuition when they get up to numbers this big, and so you might look at that and you might think, oh my gosh, I have no idea what the cube root of 729 is. It is going to get you the same answer. Either way, you'll get 9 in both cases. However, it's much easier to start with the root, the cube root, the fourth root, whatever it is, to make the number smaller before you make it bigger. It's much harder to take a number and make it bigger through squaring, through raising to the fourth power, whatever, and then make it smaller. Again, you know numbers, you know small numbers really well. But the larger numbers are harder. I would guess that you don't even know 27 squared is 729. I certainly don't know that one. And so I would have to rely on my calculator or do a lot of pencil work to get that. And then to figure out what the cube root is would, again, be a lot more work. So generally we do the cube root or whatever the root is first to make it smaller and then make it bigger, not because we get different answers, but because it's easier. Right? So if you are really a glutton for punishment, or if you're trying to test your skills of how well you remember your powers or roots or whatever, feel free to do the larger one first, but doing the power first, but doing the root first tends to be a lot easier. All right, I'm going to flip back over now. All right, so let's do one more of these and then I'm going to let you stop and do a few more on your own. So let's do this one, 16 to the 3/4. And again, if I were to rewrite this, this is the fourth root of 16 cubed. All right, now I'm just still writing it with the fractional exponent because I don't have any problems with fractional exponents. I've done them for a long time. But if it makes you feel better to write it as the fourth root of 16 like that, and then cube it because now you're more comfortable with the radical symbol than you are with fractional exponents, feel free to do that too. It doesn't really matter. All right, so the fourth root of 16, either reading it this way or reading it this way, the fourth root of 16, think about that for a second. You should know that from problem 4 because we just did that. The fourth root of 16 is 2. If you forgot that, then again, just start counting by 2s is your first choice. So 2, 4, 8, 16. So it is 2, and then we cube it, and we get 8. That would be our final answer. All right, so I want you to pause the video for a minute, and I would like you to try 11 and 14, 11 and 14 on your own. Okay, how'd you do? Let's go back and do those, and just so that you can check to make sure you did them properly. So 64 to the 2/3 says 64 to the 1/3 squared, or cube root of 64 squared. So again, you're new at this, you don't necessarily know all these, so let's just try that. So 2 times 2 is 4, times 2 is 8, times 2 is 16. Nope, too small. 3 times 3 is 9. Another 3 times 3 is 9, so 9 times 9 is 81. Nope, too small. Let's try, oh, sorry. I was only supposed to do it to the 3rd power. Yeah, 3 times 3 is 9, times 3 is 27, so no, too small. Now let's try 4. 4 times 4 is 16. 16 times 4 is 64. So that would be the cube root of 64, would be 4, because it took 3 4s to multiply up to 64. So then it's 4, and then I still need to square it. All right, so it would be 16 would be the answer. All right, and then 14 is interesting because the numerator is higher than the denominator. All the other ones that we've seen so far, it's been the reverse. The numerator has been smaller than the denominator. It really does not make a difference in terms of your strategy. We're going to look at this as 4 to the 1/2 power, or the square root of 4 cubed. All right, 4 to the 1/2, or the square root of 4 is 2, and then 2 cubed should give you 8. All right, so let's notice what happens then. If we had something that had an exponent that was less than 1, a fractional exponent less than 1, our answer was less than our base right here. That 8 we call as the base. So it was saying 8 to the 2/3 power, I'm going to end up with a smaller number. I ended up with 4, right? 27 to the 2/3 power, I ended up with something smaller than the 27. 64 to the 2/3, I ended up with something smaller than the 64. But when I have something that's larger than 1, the numerator is larger than the denominator, I get something that's bigger than that base right there, right? So I went from 4 up to an 8, right? So as that fractional exponent becomes an improper fraction, our answer should be bigger than what our number is down here, than our base. Okay. Let's skip down, and I want to look at a couple of the problems down at the bottom. Let's look at 21. And again, fractions alone just might freak you out, but let's talk about some properties of exponents, or refresh your memory about some properties of exponents that we've already talked about. So again, you remember that if you had, let's say we had x over y to the nth power, right? Then our distributive property for exponents said this would be x to the n over y to the n, that we could distribute that exponent, right? The same thing is true here, that if it's easier for you to think of this as 2 separate pieces, you can do that. So 1/8 to the 1/3 is the same thing as 1 to the 1/3 over 8 to the 1/3. Right, so just like I could distribute that exponent here, I can do the same thing and take the cube root of 1 and the cube root of 8. Again, it's harder because now this looks like 1 1/3 and 8 1/3, so you really have to be careful not to forget that this is the exponent, 1 to the 1/3 power. All right, so let me scooch this out of the way. All right, 1 to the 1/3 power, the cube root of 1. In other words, what times itself 3 times gives me 1. Well, that's hopefully as obvious as 1. And then 8 to the 1/3 power. Again, this is like the 4th time we're doing that one. Hopefully you remember that's 2. All right, so the answer would be 1/2. All right, I'm going to pause here because I think that I might run out of video time, so let me just restart the video and we'll keep going. Okay, so let me also point out here, notice that if we have something that's less than 1 under here and we take a fractional exponent of it that's also less than 1, again, these are things that you'll eventually notice, but I'm just going to point them out right now, and then sometime you might be like, oh yeah, Mrs. Taylor told me this. If I start with something small like this and I take the cube root of it, all right, so something less than 1 with a fractional exponent less than 1, notice that it actually got bigger, right? When I took the cube root of 1/8, it actually was something larger than 1/8, which is kind of weird. But think about that with numbers. If we multiply 1/2 times 1/2 or 0.5 times 0.5, we end up with 0.25. We end up with something smaller. So when we're doing the reverse, when we're taking the cube or the square root of 0.25, it's larger. It ends up, it had to be 2 larger numbers that multiply to make a smaller number. So anyway, don't worry about that if you don't understand it, but just it's kind of cool that as we take fractional exponents of fractions that are less than 1, we actually get a bigger answer. All right, let's skip to something like this. 8/27 to the 2/3, and again, this is 8, you could think of this as 8 to the 2/3 over 27 to the 2/3. And then this is 8 to the 1/3 squared over 27 to the 1/3 squared. All right, and then we're just right back to where we were back up in problem 9, because that's the exact same problem we had in the numerator, was 8 to the 2/3. So we're going to take the cube root of 8, which is 2, squared, over cube root of 27 is 3, squared. So we end up with 4 over 9. All right, now, I'm sure a lot of you are saying, Mrs. Taylor, do I have to write all these steps? No, you don't. If you look at this and you just say, oh, I know that's 8 to the 2/3, and that's 27 to the 2/3, and that means that it's 8 to the 1/3 squared and 27 to the 1/3 squared, you can skip this step right here and go right here. If you can think about 8 to the 2/3 and you realize that 8 to the 1/3 is 2, and then you're going to square it, and you want to skip right to that step, that's fine. If you are still shaky on this, then I would say please write out each of the steps. But at some point, I would anticipate that you'll go right here, or eventually, after a while, maybe even right there. Okay, let us try one more of those. Actually, how about you try number 25 on your own? So pause the video and come back when you're ready. Okay, so 32, I don't know why I chose this one. 32 to the 2/5 is the same thing as 32 to the 1/5 squared. All right, again, we've not done any 5th powers yet together on this sheet, so we're just going to start trying things if you can't figure out what 32 to the 1/5 power is. So I'm going to start with 2 because it's the smallest number. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So that's it. So 32 to the 1/5 power is 2 squared 4. Okay, I want to do, let's take a look at 28, 29, oh, and then we get into the good stuff, 30. Okay, and 28, all right, you are going to be tempted to want to distribute that exponent over the parentheses, but please don't. Remember, order of operations says do whatever's in the parentheses first, if that's possible, and then do the exponent. So in this problem, we would do 9 plus 16, and we would get 25. And then it says to raise it to the 1/2 power. In other words, take the square root. 5. Right, just to prove to us that we cannot distribute this, all right, that if we distribute it, we'll get a different answer. We have the exact same problem with each of the individual bases having that exponent. We're going to show that this does not equal 5. So it really does matter. Order of operations totally makes a difference here, that we have to do the parentheses first. All right, so 9 to the 1/2. I believe you said 3. And 16 to the 1/2. 4. And when we add them together, we get 7. So notice that these are not equal, that you cannot distribute exponents over addition or subtraction. You can only distribute them over multiplication or division. All right, so please don't try and do that distributing. Okay, let's take a look at number 30. Let's think back to what negative exponents meant. So if I had x to the -3, think back to what that meant when we did just regular exponents. All right, hopefully you remember that this means it wants to be flipped in the opposite, on the opposite side. So this x right here, which is just kind of like, you can think of that as the numerator if you imagine a 1 there, gets flipped to the denominator. But then the sign changes to the opposite. So this becomes 1 over x to the 3rd. Right, it's the same thing with fractional exponents. Here we have 36 to the -3/2. And again, that negative right there is going to indicate that we want to flip that 36 over to the opposite side of its fraction. Right, so this ends up becoming 1 over 36 to the 3/2. All right, so again, notice that we flip the 36 to the other side and the -3/2 becomes a +3/2. All right, so we'll leave that one alone. And then we're just going to do 36 to the 3 halves. So again, this means take the square root of 36 and then cube it. All right, square root of 36 is 6, and 6 cubed, again, hopefully some of you from memory work remember that. 6 cubed is 216, so it's 1 over 216. Let's do a couple more of those. Let's do this one right. Well, we just did a negative. We just did a whole one. So I'm going to make you come back and do that one on your own. But let's take a look what happens when it's a fraction. So we've got 9/4 to the negative 1/2. All right, so we've not ever had a fraction inside that negative exponent. We've always, so far, when our exponent rules when we were learning them, we just only had a base that was not a fraction. So again, we would have something like x to the negative third, but we wouldn't have something like x over y to the negative third. All right, so this is a new rule for us. But when we have a fraction inside there and it's raised to a negative exponent, what it does is it just takes that entire fraction and flips it, because the negative exponent applies to both the 9 in the numerator and the 4 in the denominator. And remember, it didn't matter where the negative exponent showed up. It always meant that whatever that had that exponent wanted to be flipped to the opposite side. So this 9 with that negative 1/2 exponent wants to be flipped to the bottom. And the 4 in the denominator with the negative exponent means it wants to be flipped to the top. All right? So we can write it in two different ways. We can write it as 4/9 the positive 1/2. All right, again, that flip is the price that we pay to get rid of that negative exponent. All right, so we don't want the negative exponent. We have to pay by doing a flip, or you could just say that it's 4 to the positive 1/2 over 9 to the positive 1/2. All right, so either way, whichever one makes more sense to you is fine. But again, just remember that negative indicates that that it wants to flip to the other side, but since there are two, they both want to flip to the other side. So the 9 and the 4 are going to reverse positions, and then the exponent becomes positive. All right, and again, you can think of this as 4 to the 1/2 and 9 to the 1/2, or you can write it out as 4 to the 1/2, 9 to the 1/2. But either way, you should get 2/3. Okay, we're going to pause again, and I want you to try one whole number 1. So if you're stuck, look back at what we did in number 36 or number 30, right? Because it was the same thing, a base with a negative fractional exponent. I mean, a whole number base with a negative fractional exponent. And then I also want you to try 33, because it's the same thing. Now we have a fraction with a negative fractional exponent, and here we have a fraction with a negative fractional exponent. So try 31 and 33. Pause and then come back when you're ready. Okay, so just like in problem 30, this 32 wants to flip to the bottom side of the fraction because right now it's in the top side. So it's going to become 32, and the price that we have to pay for that, getting rid of, that's the price we have to pay to get rid of the negative fractional exponent. So it just becomes a positive 2/5. Again, don't flip that that 2/5. Don't get confused and try to flip that. It's always the base that is doing that, reversing the order. All right, so this says 1 over 32 to the 1/5 squared. All right, so in other words, take the 5th root of 32. You're going to start to get really good at your powers of 2, but for right now, I would just say start counting. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So 5 2's multiply together to give us that 32. So this right here is 2, and then it says 2 squared. So this is going to give us 1 over 4. All right, again, 32 to the 1/5 power is 2, and then it tells me whatever I get here to square that. So 2 squared is 4. Sorry, I would have written that step out, but I'm out of room here. Okay, and then in 33, again, when it's a fraction in here with a negative exponent, it means to flip the entire thing, because both the numerator and the denominator are under the power of that negative exponent. So they both want to flip to the opposite side. So this is going to become 64 over 49, and then when we make that switch, the price that we pay is that negative exponent, all right? So it becomes a positive 1/2. All right, again, feel free to write it as 64 to the 1/2 over 49 to the 1/2, but again, I'm kind of squished here, so I'm just going to do it one at a time. So 64 to the 1/2 power, in other words, the square root of 64, 8. And then down here, 49 to the 1/2, the square root of 49 is 7. So final answer, 8 sevenths. Okay, and then let's just quickly look at the bottom row. This is just kind of reminding you that, don't forget, you might see it like this with the radical symbol. So this is just the 4th root of 81, what we have so far been calling 81 to the 1/4 power. All right, and again, we're saying what number times itself 4 times gives us 81. So we've already done 2 times 2 is 4, times 2 is 8, times 2 is 16, 2 is too small. And then if we try 3, we find that that's it. All right, so the others here, 37 through 40, are all just getting you to remember that this is the same as our fractional exponents that we've been working with. Okay, hopefully that was helpful. I'm going to post this link to this video on my school so that if you feel like you need to go back and watch it again, you absolutely can. All right, next video coming up momentarily.